Hello.
Hi Kiran. Hi everyone.
Hi there. Very good morning.
Hi, good morning.
Hi, good morning.
Just give me 2 minutes.
Yeah.
Then we'll start.
Okay.
Okay, fine. So yesterday we have seen that till channels, right? So that part we have completed. Also, Kiran, I have shared one complete session plan. So just
Okay.
have a look. So total 37 hours I have kept there,
Mm-hmm.
but like 5 hours here and there. Just
Mm-hmm.
take as a buffer.
Yeah, that should
Because
be fine.
sometime if we get any issues and
Mm-hmm.
so if that issues takes time, then that may will extend, but 37 hours or 38 hours should be enough for the complete.
Okay. Okay.
Okay.
Yeah, sure.
Yeah.
Definitely, there are going to be some changes, but we
Mhm.
have planned. There will be something in front of us on the
Yeah, so
tentative
plan.
timeline. Yeah.
Yes, so complete plan I have given there.
Okay.
Just
Great.
have a look. Yeah.
Yeah.
Okay. And also, yeah, please make me co-host so I can share my
Yes.
screen.
Yes. Yes. Yeah, I've done that.
Okay. Okay, so now let's continue with the channels part. Okay, so we have seen the channels yesterday. What is
Mm-hmm.
a channel? So it is a communication medium, basically. And after that, let's try to understand what is an identity. Okay,
Mm-hmm.
so identity is something like a, it's just like our physical identities, which right now we are having, like Aadhaar card or PAN card, right? So basically,
Mm-hmm.
identity proves yourself. Okay, this is you, and this is your basically identity. Okay, so since we are working in the private blockchain, and to get inside the private blockchain, uh, everyone who is taking part or who is trying to join the network, he should have the identity first. So that is the very first requirement of the Hyperledger Fabric network. Like if you want to join the network, you can be a user, you can be an admin, you can be a peer also, uh, right? But if you are trying to join, or if you can be order also, okay, any type of node, any type of user, or any type of admin, if you are trying to join the network, the very first requirement is you should have an valid identity. Okay, so that is a very first requirement of any fabric network. Okay,
Mm-hmm.
why? Because it is a permission based system. Without permission, without knowing who are you, and what kind of role you are having, what kind of access you are having, it, system will not allow you to enter into the network. Okay, so that is the very first concept of identity, and it is very similar to our Aadhaar card. So or you can say your employee ID or employee card for your company, right? So without that card, it is they will not allow you to enter into the premises. Similar way here also, if you don't have the identity, then it is not you are not allowed to enter into the network. Okay, now how your identity uh, uh, will be created or will be issued. So basically, in the identity, you will have the certificates, digital certificates. Okay, so what is a digital certificate now? So digital certificate is a document which holds a set of attribute related to your identity. Okay, and so basically it will have private key, public keys, your some serial numbers, right? Then it will have the which kind of algorithm you used, which type of standard you have used to generate the certificates, right? So that is the that is a certificate, that is a digital certificate. Nowadays, if you see any kind of any websites or any system, everything works on digital certificates only. Okay, because whenever we talk about the security, okay, so the very first thing will come here is how you get the security on the internet, right? So on the internet right now we are using https, right? So how the https is having the security, because it is using the, it is encrypting every all the data which is coming from the server with the encryption with the help of digital certificates. So if I open this digital certificates for docs.google.com, so here you can just go, connection is secure and certificate is valid. And if I open this certificate here, okay, so here this is this certificate issued to stargoogle.com. So any website or any subdomain which comes as like docs.google.com or sheets.google.com, right? So everything, every domain will use this certificate. Okay, now if you see uh, here, so this is the X509 type of certificate. Okay, and here in detail if you go, so you first thing you will find is issuer name, who has issued this certificate. Okay, so every time whenever you get any kind of certificate, there will be a person or there will be an organization or there will be a tool who is going to issue you the certificate. Okay, so that issuer name you can see here is Google Trust Services LCC. Okay, and this organization which you see here, Google Trust Services LLC, this we call as a certificate authority who issue the certificates. Okay, so remember one thing, always your certificates will be coming from a particular organization. That organization will call it as a certificate authority. Okay, so the main job of certificate authority is issue the certificates to the participants. Okay, after that, if you see the serial number, this is the serial number. Then the algorithm, which algorithm they have used, so they have used the SHA-256 with RSA encryption. After that, your public information you will get here. So in public key you will get the algorithms, parameters, then your public key in the bytecode, then size and everything. Okay, after that some another type of information you will get, and at the last, okay, so this is used by these many websites, you can just check it out here. And at the last you will get the type of this certificates. So type is X509. So this certificate is X509. And in the Hyperledger Fabric also, Hyperledger Fabric only support X509 type of certificates. Okay, this is the valid standard which is supported by, or which is so Fabric is only compatible with the X509 standards. So that anytime if you want to issue the certificate, or if you want to get the certificate from the certificate authority, the very first thing you have to do is you have to check out which type of certificates that certificate authority is issuing. Okay, so always remember you have to get the X509 type of certificates.
Okay. We can't use this open SSL or open certificates.
See, you cannot use any other type, open SSL or any other type which is right now available. So only X509 type of certificates you have to use in the Hyperledger Fabric. Now there are multiple ways. Okay, so let me go to digital certificate also. So now you I think you understand what is a certificate authority, right? What is a certificate? What is a certificate authority? So basically, certificate authority is the one who is going to issue the certificates, right? So now what happens is there are multiple ways to create the or issue the certificates. Okay, one way is so in the Fabric we have two ways. Okay, so one way is like for the learning purpose or for the development. Fabric provides a tool. Okay, it is not an organization, but it is a tool, binary tool, and that binary tool name is Cryptogen. Okay, and with the help of CryptoGen, you can create or you can generate your certificates. Okay, that is for very basic. That is not for recommended for production use. So for only for learning, because uh, the very first thing is certificates, right? So where like how you will set up the your organization to issue the certificates, that is a complex process. So to make it simple, they have created a binary, and for development purpose you can, or for learning purpose you can use that binary and you can generate your certificates. Okay, another way is setting up your own certificate authority. Okay, so that is done by Fabric CA, Fabric Certificate Authority. Okay, so that also we can set up in our laptops, in our machine. Okay, but that is a bit complex process. That is why it is not straightforward, and CryptoGen is a very straightforward. So what I do is generally I first teach the CryptoGen tool. If first people learn about the CryptoGen, after that it will be very easy to understand the Fabric CA. Okay, and the third way which we have is the using some third party certificate authority. Okay, like these are third party companies, they're like Let's Encrypt, or just now we have seen Google Trust Services, right? So these are the certificate authorities who issue the certificates, but those are third party services. Okay, so third party meaning some third party companies are there, their main job is to issuing the certificates. So that is also that is also can be used. Okay, so we can integrate with the third party certificate authority, and we can use their services to get the certificates. Okay, so mainly these three ways you will be having to get the certificates in your Hyperledger Fabric network. Okay, now for in this particular training we are going to learn about CryptoGen and the Fabric CA, how you will set up your own certificate authority. Okay, so mostly in the Fabric network we use our own certificate authority only, which we are going to set up. Okay, now in the certificate authority, the another one thing I just wanted to show you here. 1 minute. Okay, so here if you see, let me open this. So in this certificate, another concept which you can see here is this is GTS root R1. Okay, so this is root certificate authority. Okay, and this is GTS CA 1C3. This is intermediate certificate authority. Okay, so now what is what is the concept of this root CAs and intermediate CAs? Okay, and then this intermediate CA issue the certificate to this particular entity, google.com. Okay, so generally what happens is in the certificate authorities. Okay, so what they do is, so just like in our organization, like in your company or in your organization, what happens is if one employee is there, okay, he is a junior employee, and there we have the hierarchy, right? We have our team, then team lead, then your manager, then senior manager, then your executive level people, right? So this is our one hierarchy is there, correct? Now what happens is, as you know, like certificates will be coming from the certificate authority one, right? So let's say in your organization a junior employee is there and he wants to take leave for 5 days. Okay, so he is not going to take leave from your executives, from your CTO or from your CEO, right? Or from your senior manager also. Max, he will go to your team lead. Then team lead, if he is authorized to do that, he will approve the leave, or he will ask manager. So your manager will approve the leaves, right? But who has given the authority to manager to approve the leaves? Of course his senior, like senior manager has given the authority to the manager to approve the leaves for the employees, correct? So here also and when in this scenario, what is happening is there is so let's say if only one person is there who is like senior manager is there, and every leave should be approved by him only, and there is 1,000 employees in your team, right? So everyone will go to him, and then he will be doing only approving the leaves, right? Nothing else he will do, correct? So to reduce the load for from a particular person or from particular entity, what we do is we create these kind of hierarchy, and the hierarchy what we do is we provide a like some kind of approval on behalf of me. You can also approve the leaves, or behalf of me you can also generate the certificates. So here also the same concept works. We have the root CS, that is the topmost certificate authority. After that he will assign some intermediate CS, so he will give authority to some intermediate CS also. Like that you can issue the certificate on behalf of me. If anyone comes to me, instead of coming to me, you can just take the request, and then you can issue the certificates. So that is the job of intermediate CS. Okay, so root CS and intermediate CS. Okay, this is the two concept which comes in a hierarchy. Okay, so very simple term, if you want to understand, root CS is your senior manager, and your intermediate CS is your manager. Simple. Okay, yeah.
Yes.
Now, the very most important thing comes here, that is the MSP, membership service provider. So let's understand what is the MSP and why it is needed in the Hyperledger Fabric network. Okay. So if you recall, the very first thing is what we need in our Hyperledger Fabric network is identity, right?
Mhm.
But if only identity is required, then anyone can come and have the identity, and then they can enter into the network, right? So that is possible, because if someone is coming with the valid identity, and if you don't have anything else, only one criteria to have the identity and enter into the network, then anyone can join the network, because nowadays getting an identity is very easy, right? Correct. But here one concept comes, that is a membership service provider. Okay, for an example, let's say you have three type of credit cards, okay, in your wallet. You have a Visa card, a MasterCard, and the MX card. Okay, three type of credit card you have. All three are valid. All three have money. Okay, and when you go to one shop, and there you want to buy something. Okay, and there they have put it one poster like, we only accept Visa and MasterCard. We don't accept the MX card. Okay,
Mhm.
but you want to buy with the MX card only, right? So what happens is, you have the valid identity, so you have the valid MX card, you have money also, you have everything which is required. Okay, still the shop is not allowing you to buy something from the MX card. Okay, so the same concept works here also. You can have the valid identity, okay, but if you are not part of the MSP, so basically in the shop, what he is doing is he has enabled only two type of cards only. So he has the infrastructure for only two type of card. Okay, so basically he added two type of card in his list, which he is going to allow. MX is not added in their list, correct? Similar way, here also in the Hyperledger Fabric, you can come with the valid identity. That is not an issue. But the every organizations or every network will be having a MSP. MSP is nothing but the collection of identities. Okay, that is a special type of identities. So if you want to be part of the network, then you should be part of MSPs. Okay, so in general, what we are going to have is, every organization will have their MSP. Okay, so org1 will have their MSP, org2 will have their MSP, and other organization also have their MSP. Okay, as a user, if you want to be part of the network, okay, so the very first thing is you have to be part of any MSP. If you are not part of the MSP, you cannot be part of network. Okay, so basically your identity should be part of, or your identity collection or whatever you have, that should be part of MSP. Okay, so this is the concept of MSP in the Hyperledger Fabric network. Clear?
Yeah. Yeah.
So everywhere in the Hyperledger Fabric, we'll be talking about MSP and NMSP. Okay, whenever we talk about the authorization, or whenever we talk about the access or permission, MSP will come there. Okay, and in a very simple term, it is a collection of identities.
Mhm.
Okay,
Yeah.
so now just look at the diagram and let me know what you understand by looking this diagram. So we have seen MSPs also, we have seen RCA and ICAs also. So RCA are root certificate authority and ICAs are intermediate certificate authority. Okay, and we have two
Mhm.
organizations here, right? Correct.
Yes.
So basically, if you see here, in the organization one, only one MSP is there, meaning only one collection of certificates are there. That is org1.msp. Okay,
Mhm.
so all the members who are part of the organization one, they should be part of org1.msp. Okay, and that can be issued by ICAs also. So you can see a trust of chain of trust is there, right? ICAs and ICAs and RCA. So basically this RCA allowed this ICA, then this ICA allowed this ICA to issue the certificate. So basically you will get the certificates you can get from this ICA also, this ICA also, this root certificate authority also. Okay,
Mhm.
right? But
Yeah.
in the organization two, if you see, we have total three type of MSPs: national, international, and government. Okay, so basically three different groups inside one organization.
Mhm.
Okay, so one is org2 MSP and national, org2 MSP international, org2 MSP government. So let's say some users are there. If you want to put those users inside the national MSP, so you can put their identity into the national. If some international users are there, you can put them into international. And some government employees are there, if they are also part of your organizations, so you can put in them government. Okay,
So can we say that government and MSP is most secured one because it has only one authority for approving RCA?
no. All has same security. See, only
Mhm.
difference is, see, this is the certificate here. Let's say in the national, if you
Mhm.
have number of users are moved. Okay,
Mhm.
so instead of putting load to one RCA, we have just
Mhm.
given distributed to 50-50. So half this ICA can issue the certificate, half this RCA can issue. Let's say 1 lakh count is there, right?
Mhm.
1 lakh
Mhm.
users are there who need the certificates. So
Right.
50,000 this ICA can do, the 50,000 this RCA can do.
Mhm.
In international, 50-50, or whatever ratio you want to have. You
Okay.
just reduce the load on a single certificate authority. Because
Mhm.
see, whenever, let's say in the Fabric network, whenever you join the network, okay, let's say someone is
Mhm.
trying to join the network, you are registering someone. So the very first thing is issuing the certificates, right? And let's say at one time 10,000 users are signing up. Okay, so you have to issue the certificate also that fast, right?
Mhm.
So that is why instead of giving a complete load to a single certificate authority, we just use multiple certificate authority, but all comes in the from the same family only. Okay, so this RCA
Mhm.
is part of this this ICA is part of this RCA only, because RCA only delegated access to ICA, right?
Yes. Yeah.
So this is how it works.
Mhm. Okay.
Okay, so next is, now we understand what is root certificate authority, what is intermediate certificate authority, as well as we understand what is the MSP. Okay, now just look at this diagram. Here I will explain you what is a local MSP and what is a channel MSP. Okay, so basically two types of MSP we will find, we will have in the Hyperledger Fabric network. Okay, so two type of collections, identity collection in a very simple term. Okay, so the very first thing, if you see, org1 is there. This is org1, this is org2. So basically two organizations are there. Okay, this is org1, this is org2, and they have their certificate authority, separate certificate authority, that is RCA1 for org1 and RCA2 is org2. So basically this RCA1 and RCA2 will be issuing the certificates. Okay, so these are RCA1 and RCA2, they can issue the MSPs also. Okay, so basically when we generate the certificates, we'll get the MSPs also along with that. So now what happens is, this L is my ledger. Okay, P is my peers. P is peer, L is ledger. Okay, C is channel. So these keywords are clear, right? So basically one channel is there, both the organizations part of that channel, and both are having one peer. This is one peer for org1, this is peer for org2. Okay, now what happens is, the very first thing comes here is the local MSP. Okay, so local MSP meaning, if you want to be part of any network, okay, as a user, if you want to part of any any network, the very first thing is you should be part of local MSP of any organization, any one organization. Okay, let me repeat that. The very first thing is, if you want to part of any network in the Hyperledger Fabric or any Hyperledger Fabric network, the very first thing is you should be part of local MSP of any one organization. Okay, so the very first requirement, be part of local MSP. Directly, if you come without an organization, you cannot be entered into the network. So similar way, let's say there is a hackathon going on. Okay, and two companies are there, and they are allowing only two companies. Okay, let's say your company and another company is there. Okay, now like, if you are outside these two companies, you cannot be part of that. Okay, so if you want to part of the hackathon, the very first thing what you should be having is, first you should be part of your company. Right? If you are part of your company, by default you will be allowed to the hackathon. Correct. Similar way, if you want to be part of network, the very first thing is, if your organization is part of the network, obviously you will be, by default you will be part of the network. Okay, so every organization will have the list of identities, or the collection of identities, and your identity should be part of that, and that we call it as a local MSP. Okay, so the org1 MSP which you see here, that is the name of local MSP or org2 MSP. The purple, this is okay. Clear? Local MSPs are clear? Or should I repeat?
No, it's quite clear. So
Yeah,
right,
can you
guys?
repeat? No.
Okay. Yeah. Please repeat.
Okay, so the very first thing is, so basically we will be having two types of MSPs, local and channel. So for the first thing is local MSP. Okay, so MSPs are the collection of identities, right? So every organization will have one MSP. So here in the diagram you can see org1 MSP for org1, org2 MSP is for org2. Now if you want to be part of the network, the very first thing is you should be part of any one MSP. Okay, from any organization. You can be part of org1 MSP or you can be part of org2 MSP. That is the very first requirement. Okay, and this MSP, the very first MSP which you see, org1 and org2 MSP, this MSP we call it as a local MSP. Okay, so this is the concept of local MSP, and these MSPs are coming from RCA1 and RCA2, that is root certificate authority. Okay, So all the certificates will come from the certificate authority, MSPs will come from the certificate authority. Okay.
Yeah.
Now coming to the next part. Now in the below you can see channel. This is my channel. Okay. Now if so, the very first thing is you have to be part of the network. Second thing is, as you know, like if you want to do any kind of transactions in the network, you have to be part of any one channel, right? Yes or no? Yesterday we were discussing that, right? Without channel, you cannot do any transactions. Okay. Now, how organization will get the access to the channel? Okay. So every organization have their local MSPs, org1 MSP and org2 MSPs, right? So basically, if a channel is there, let's say channel name is channel 1. Okay. If any organization who want to be part of a particular channel, so their local MSP should be added to the channel MSP. Okay. So that channel MSP is the second name, or the alternative name, we call it as a global MSP also. So don't confuse with channel MSP and global MSP. Both are same. So basically, this is the collection. This is a global MSP, and if organization 1 and organization 2 wants to part of the channel, then their MSP should be added to the global MSPs. Okay, and now if your identity is already part of org2.msp, okay, meaning you are part of organization 2, so by default you will get also access to the channel.
Okay, so it is not necessary that users that are having valid identity for org2msp and they want access to the channel, they don't necessarily needed to have identity for org1 MSP as well, right?
No,
it can be or.
Or always or. Okay.
Or
user cannot be part of multiple organizations.
Multiple, yeah.
Okay. Just like our employment, right? One cannot be part of multiple organization at the same time, right? Similar kind of thing, right? So similarly here also. So local MSP and global MSP. So like this, let's say right now only one channel you can see, but let's say 5 organizations are there. They have their local MSP, org1 MSP, org2 MSP, org3, org4, and org5 MSP. Okay. This is my channel 1. Okay, consider this is my channel 1. Only 2 organizations that are there. So what we will do is we'll add 2 org1 MSP and org2 MSP, so that only 2 organizations will be part of this channel. In the second channel, if you create here and if you want to give access to 3, 4, and 5, so simply you have to add org3.msp, org4.msp, and org5.msp in the global MSP of channel 2. That's it. Then your organization will be part of that particular channel. Okay, so this is how we manage the channels as well as the MSPs.
Right. Clear? Yes. Clear, all right?
Yes, yes.
Okay. Now, the next thing is, so yeah. So the next thing which we have here is the MSP structure. Okay. So yeah. So MSP structure is like in which what kind of structure is there? It is a folder structure basically. Okay. So whenever we generate the MSPs, okay, so the MSPs will be generated in this structure. Okay. So you will have the root CAs, intermediate CAs. So basically in root CAs, your root certificates, authority certificates will be there, or identities will be there. Then intermediate certificate authorities, identities. Then organization units will be there, admin certificates, revoked certificates, then sign certificate, key store will be there, well, private keys will be stored. Then TLS root CS and TLS intermediate CS. So basically, this is the complete uh, structure, folder structure of your MSP. Okay, so every MSP will come with this kind of structure. So that structure we'll see in practical when we generate these certificates, how it will look. Okay, so that we are going to see. But main thing to understand here is whenever you generate the MSPs, this is the structure you will get. Okay.
Mhm.
Now coming to the next topic, which is the ledger. Okay, so as you know, like in blockchain, the database, we call it as a ledger. So that is a ledger, simple term, that is a database. Okay, in Ethereum you must have seen the ledger, right? So in the ledger what happens is your transactions will be there, and they will be stored in the blocks, right? So basically you are creating a chain of blocks, correct?
Yes.
But in the Hyperledger Fabric there is a minor difference. Okay, what is a minor difference here is, so in the Hyperledger Fabric, the ledger will have two parts. Okay, first one is world state, second one is blockchain. Okay, so
Mhm.
ledger is one, but it has two parts, world state and blockchain. So now let's try to understand what is a world state and what is a blockchain. So this is my ledger, it has world state and the blockchain. So basically what happens is, um, let me give you a very simple example and then it will be clear. uh, let's say uh, today you did one transaction, you have an asset, let's say that asset is a car. Okay, and asset id is let's say car 10. Okay, that is my asset id. So today I bought that car and current ownership is with me. Okay, current owner of that car is muscle. Okay, and that transaction got stored in the block number 15. Current block number was 15, so that transaction was stored in the block number 15. Now after 2 months I want to sell out that car. So basically sell out meaning I want to change the ownership of that car, correct? So
Yeah.
now what will happen is the current block number, which is right there in the system, is block number 1000. Okay, so after my transaction, um, around 985 blocks were created. Okay, and current block number is 1000. Okay, so just visualize, if your system wants to get my car information, basically if you want to do a transaction, you have to first search the existing record in the system, right, in the blocks. So if you want to get the complete information about my car or my car metadata, then what will happen is you have to search in those 985 blocks, correct? Searching in a block or searching in any kind of database, it takes time, correct? And that is the main problem of any blockchain. Okay, because on the performance side, blockchains are like a very bad. Just look at the Bitcoin or just look at the Ethereum also. Okay, so whenever we do this kind of searching, right, so it is very difficult to get the good performance, right? In the Bitcoin, in every like your transaction is not confirmed within seconds. Okay, it takes minutes. Why it takes minutes? Because these kind of checks are going on. Okay, that is why it takes time, right?
Mhm.
So Hyperledger Fabric, what they thought is, uh, why don't we create a index on top of blockchain? Okay, so how we create index on top of blockchain? So they have created world state.
Mhm.
So in the world state, what happens is, like, your complete blockchain transactions will be stored in your main blockchain only. Okay, but the current state of every asset, okay, current
Mhm.
state of every asset will be stored in the world state. World state is a kind of non-blockchain. It is not, the transactions, the data will not stored in the blocks. It is a very simple non-blockchain database. Okay, so
Then in what format does it store?
it
In
is
key
stored in
value
the
pair or?
NoSQL. Yes, key value pair. Yes, same
Oh,
for
okay.
the
So,
MongoDB format, basically
mhm.
key value pairs. So,
So
but
in
the
short, we can say that it's indexing database for blockchain.
correct, you can say that. So basically, but it is integrated. It comes along with the fabric. Okay,
Right. Mhm.
so you can of course change the database engine. So by default, level DB will come, but if you want to change, you can use couchdb also. Okay, so
Mhm.
but that you have to use. So world state is kind of indexing. So whenever you have a transaction, let's say right now, for this same example, when I bought a car, okay, so current ownership with me, so the car ID is 10, and the current ownership detail or the current metadata will be stored in the world state, okay, with one record. So car 10 is there, and the complete transaction will be stored in main blockchain. So whenever next time I want to do a ownership transfer, so the system will not look inside the main blockchain. It will just go to the world state, and in the world state, it will search for my ID with the indexing, and then it will get the complete detail of or complete metadata of that particular car, and it is latest also, because there is no duplicacy. Only one index will be there for my car, and that will have the latest values. If you search in the main blockchain, if that uh, uh, car is sold 100 times, then 100 records you are going to have, right? Correct, because blockchain is all about history.
Mhm.
So all 100 records you will have there, and you have to search it out on the basis of time, which is the latest record, and then you have to search, and then you have to do the again ownership change of from that particular record. But in the world state, always remember, only current state will be stored. Okay, just look
Mhm.
at this diagram. So here you can see two keys are there, car 1 and car 2. Values are there, Audi, and here the values are type, BMW, color red, honor, J. Okay, here we maintain the versions. Okay, so right now let's say the car 1 is there, value is Audi. Okay, that is on version 0. Now you want to change, so key will be same, but value you want to change, so Audi to BMW, so version will be 1. Okay, so this is how in the world state we are going to store our current state of all the assets. If you have 1 lakh asset, all 1 lakh asset data will be available there. Okay, and it will be stored in a key and value pair. Clear?
At both of the places, it is showing version 0 only for
Sorry.
record 1 and record 2.
The default version will come as a version, so they start from version 0. Okay, let me give you one, let me open one database which is right now running. Let me open that. I'll just show you how it looks like. So this is the couchdb. Okay, so we can use the Hyperledger Fabric with the cows, like we can just integrate with the couchdb also. Okay, so this is my, just give me 1 minute, I'm just getting one call. 1 minute.
Yeah.
Okay, so you can see here, let's say this is one record, this is one metal, and this is one record. So this is how the record will be created. So it has like, it will have the ID, then your fields, whatever keys you want to define, doc type, icon, ID, name, updated at, right? Then version also. Okay, so this is how we are going to have the world state in the Hyperledger Fabric. Okay, but now one question come with regards to security, right? Like if someone is able to see this database, he or she can
Right.
modify also, right?
Yes.
Correct.
That's what I was wondering.
So the thing is, as you know, this is not a centralized database. This is a distributed database.
Okay.
Correct. So right now, which I'm accessing is only one peer database or one peer ledgers. Likewise, you will have multiple peers. So multiple peers will be having their world state. Okay. If you do any change here, and if you store, you are only changing in your peer. Okay. You're not changing on every peer at the same time. You have to change on all the peers at the same time. Then only it will be valid, and that is next to impossible because in the production environment you are not having one or two peers. Of course, you will have the more peers, right? And every peer will have their own security consideration, right? So if you change here, then next time whenever this metal or any particular transaction happen on this particular record, your endorsement will be failed. Okay, so that is how we manage to have the security in place along with the indexing. Yeah. So this is all about the world state, and next we have the traditional blockchain. So in the traditional blockchain, what happens is, of course, you will have multiple blocks. Then your transaction will be stored on those blocks. Simple. Okay.
So while making the consensus for accepting the transaction, it will validate both world state and the blockchain.
No, it will only validate. No, it will. So for a particular transaction, it will validate the world state only.
Okay.
Okay. Block validation will come into the picture when a block will be added to the blockchain. Let's say one block has been created by the order. Okay. That block has, let's say, 10 transactions. So when that block is going for commit, so of course the block will be going to every ledger, every peer's ledger, and they are going to commit that block. Correct. So that time the block validation will happen, like what is the previous hash, what is the current hash, and all those things will happen there. But at the time of endorsement, only world state is in picture.
Okay.
Okay. And also that the read write set, which I told you, right? So that read write set peers will be creating by looking at the world state. Okay, so they will just check out the world state and they will create the read and write set.
Okay.
Okay, so moving on. Moving on, we have the smart contract and the chain code. Okay, so now the very basic difference. So smart contract, I think you guys know what is a smart contract and the chain code.
So it's basically a custom logic that we build.
Yes.
The main business logic.
So whatever logic you have for your business, so that logic you are going to write in a coding language. Okay, that we call it as a smart contract. Now, what is the chain code then? What is it? This is a new term here, right? So basically, a minor difference would be there. You can write multiple smart contracts, but when you are going to deploy in the Hyperledger Fabric, you are going to deploy as a chain code. So chain code is basically a collection of smart contracts. So by looking at the diagram, if you see, We have vehicle chain code and the insurance chain code. But inside vehicle chain code, you can have multiple smart contracts. Like for a car you have a contract, boat, truck. You can have multiple contracts inside a single chain code. Similar way, insurance chain code you can see. It is not necessary you will have to have multiple contracts only. Okay, only single contract also you can deploy with the chain code. Okay, so basically one, minimum one, and more than like more any number you want to have. So when you create the collection of these contracts, that we call it as a complete collection, we'll call it the chain code. And when we deploy this chain code, it will go as a package. Okay, so always remember, whenever you are going to deploy the chain code, first we have to create a package, and then package will be installed on the Hyperledger Fabric network. Okay, and the last we have here is the system chain codes. Okay, so now there is a two things. Okay, there are two things. One is application chain code. Second one is the system chain codes. So the logic which you are going to write, that is the application chain code. Okay, so for your business, with the logic which you are going to write, that is a business, that is the application chain code. But there are some system chain codes. With the help of those system chain codes, your Fabric network is run. Okay, like if a framework is there, that framework is also dependent on some code, right? Some code should be running at the back end, then only it is running. For an example, your Excel or your Word application, right? Some code is running at the back end, then only you can see the Excel and you can create something with the help of Excel. Correct. Similar way, here also, to run the Fabric, of course, some chain codes will be there which will be running, and those chain codes we call it as a system chain codes. Okay, so types of those chain codes are LSCC, lifecycle system chain code, endorsement system chain code. Sorry, I repeated that, my bad. And then CSCC and QSCC. Okay, so these are the chain codes which right now we are having in the Hyperledger Fabric. So let's say very first is lifecycle system chain code. Okay, so what is a lifecycle system? So your transaction have a complete life cycle, right? So starting from your proposal to the last validation and commitment. So complete life cycle will be managed by one chain code. Then we have endorsement system chain code. So endorsement system chain codes meaning whenever an endorsement process is going to happen, that in that time endorsement system chain codes will come. Then we have configuration system chain code. So whatever configuration we are going to do in the Hyperledger Fabric, so all configuration will be managed by configuration system chain code. Okay, then query system chain code. So query system chain codes is whenever you are going to query something. Okay, let's say you want to fetch the data from the Hyperledger Fabric, then that time the query system chain code will come. Okay, yeah. So these are the type of system chain codes. One which I have missed out here is that is VSCC. Okay, so that is validation system chain code. So validation system chain code will be used when you are going to commit the new blocks and the transaction into the peers ledger. So that time all peers will have the proper validation, and that chain code we call it as a validation system chain code. Okay, so these are the system chain codes which are available. And if you want to again go back and have a look how this system chain codes look like, there is a, so you have to just go to GitHub and Fabric. Okay, and here if you just search for let's say VSCC. Okay, so this is your so in the core, 1 minute, let's go here only. So you have to go to core, then here we have SCC, and here you'll find LSCC, QSCC, CSCC. Okay, and these are the chain codes available. So let's say, let me open LSCC. So this is my LSCC code. Okay, and it has, so LSCC lifecycle chain code, right? So for your chain code, complete lifecycle will be managed by this. So chain code lifecycle command. So install, deploy, upgrade, get ID, everything. Okay, all the functions are written here. So whenever we do like okay, we are installing a chain code, but directly it is not going to install. It will run these system chain codes, and then your application chain code will be installed. Okay, so behind the scene, these are the chain codes which will be running. Okay. Next we have is the transactions. Okay, so transactions, as you know, like every operation which we do on the blockchain, we consider as a transaction, right? And type of transactions we are having, we have deploy transaction, we have invoke transaction, query, and cross chain code. So basically what happens is, the very first type of transaction is deploy transaction. Okay, so in the deploy transaction, what happens is whatever you do with the help of on the system, let's say creating a channel, joining the channel, then deploying a chain code, then approving a chain code, committing the chain code. So these are the system operations, right? Because you are doing on the system, you are not doing anything for your application. So those transactions, we call it as a deploy transactions. Then second transaction, we do the invoke transaction. Invoke transactions are the one which we are going to do. Let's say whenever you are going to write something to the ledger, you will be doing invoke transaction. Okay. So let's say you want to create a new car asset. So that time you are going to invoke a transaction. So that type of transaction would be invoke. Then query transaction. So whenever you are trying to read the data from the ledger, so that time the transaction would be query transaction. Then cross chain code transaction. So there is a way, if you have two contracts, okay, or two chain codes basically, and one function is written in a second chain code, and if you want to call that chain code function from the first chain code, so that is a cross chain code transaction. You are calling a function which is written in a separate chain code. Okay, so that transaction, we call it as a cross chain code transaction. Okay, so basically these four types you will see in the Hyperledger Fabric. Okay, so the first three we are going to do in our practicals. Cross chain code, when we write two chain codes, then we can use the cross chain code also. But three you will see in few very next classes only: deploy transaction, invoke transactions, and query.
Okay.
Okay.
Yeah.
So
Cross-chain code transaction also may be quite frequently used, right? Because we may need to communicate between different chain codes.
yes, if you have multiple chain codes, then of course that is a frequent one. Okay. And next one is block and transaction structure. This is very complex one. Okay, so I will explain you when I explain you the EOV approach, or when we discuss about the transaction lifecycle. So that time I will explain you, because this is the one which is like a when a transaction is going, okay, how your transaction structure will look like, and how your block structure will look like. Okay, in the main blockchain or in the Bitcoin, you must have seen the block structure, right? How your block, what kind of things your block will be having. But this is the actual structure of your Hyperledger Fabric block, and as well as the transaction.
Okay.
Okay. So Okay, so that's it I have for today, and most probably tomorrow also we'll have a theory, and
Mhm.
then continuous will have the practicals.
Okay.
Okay.
Yeah.
So only few things which is left: transition life cycle and uh, private data and the runtime structure. So only few things we are left in the theory part. So be ready with your machines. Okay.
Yeah. We do.
And
We are having Ubuntu systems. Right?
okay, yeah, perfect then. So what we are going to do is, so here let me open that, so we'll have a quick discussion on that also. It is asking for download. Okay, so only transaction. So this part 2 is pending and transaction lifecycle is pending. Only these two theory sessions we have, and then we'll start with the Golang. Okay,
Mhm.
so Golang I have given 3 days. Okay, we'll try to complete as soon as possible. It has some practicals I will share with you. You guys can just run those practicals.
Mhm.
We'll try to complete in 3 days. So just let me know what is your plan for next week. Like, are you guys having holidays and all?
No, no, we don't have any holidays because Christmas lies on Saturday, so we'll not be having any extra holiday.
Okay. Okay. I might not available on 27 or 28, mostly 28.
Okay.
Okay.
Yeah.
So on that
You can let
one,
me know. That will not be an issue.
okay, fine. 28 and 31st, these 2 days I might, but like 28th is pretty much confirmed, but let me check. Okay, it is
Mhm.
not
Yeah.
100% sure. And so that's it. Then I think we are good.
Okay.
So yeah, so tomorrow we'll try to complete both transition life cycle and second part,
Mhm.
and then we'll move to the go line.
Okay.
Okay.
Yeah.
Okay, fine. Sure. Yeah. Thanks everyone. Thank you.
Okay. Thanks. Thanks,
Bye
Aaron.
bye.
Bye for
Thank you.
now. Have a good day. Bye.